So welcome to Forget the Storage Permission. It's not often we go to a tech conference and get to go to a talk where we're specifically going to be forgetting things, but it's the end of the barbecue. So hopefully we'll actually learn a few new techniques which will just replace that knowledge rather than totally void it out. We'll save that one for later. But really trying to reduce when we actually need the storage permission. So this would be write and read external storage. So a little bit about myself. I've been doing Android development for just about 5 years now. Kind of started on my own, but then got a job doing it full-time at Funware, and then joined Facebook. Sorry, I didn't fix everything I want. Did a lot better. But for this last year, I've been working at Google as a developer advocate, kind of working both with the community and with the internal engineering teams. Primarily been focused on an advanced Android Udacity course. This is online learning, kind of taking your app to really be production ready, all those little things that really make an app that much better. And then, of course, just recently launched Android Development Patterns with Joanna Smith, kind of best practices in Android, covering a lot of the APIs as well as kind of the reasons why behind some of these things. My focus primarily has been kind of the Android framework and Android support library, and we'll be kind of talking about a lot of those things today. So we're going to be forgetting things. We're going to forget the storage permission, but to really forget it, we need to know kind of what was it giving us in the first place. So let's start at the beginning, kind of where can we actually store data? So first, there's this concept of app-specific storage space. So as you'd expect, these are directories which are specific to your app and to each user. Now, one important thing about all of these directories that will be covered here is that they're all completely emptied and destroyed when your app is uninstalled. So it's really easy to say, okay, well, I have now completely uninstalled the app, and now all of the data associated with it isn't left lingering on my device. And there's kind of two main types of these directories. There's private directories stored on internal storage. So these are accessible via getFileDir and getCacheDir. So as you can imagine, getFileDir are for kind of actual real files, user data, while getCacheDir is more for caching files. Say if you were to download large images from the internet, this would be a good place to store them because when you run low on memory, this space can be cleared without actually harming users' data. Now, the other side of things are these concept of external directories. And I'll use air quotes because they're not actually external. On many devices, like Nexus devices, they're actually on the same flash drive as the internal storage. It's simply just a different partition of the same space. But in all cases, it's actually that those external directories are the ones that are readable by all apps that have these storage permissions. So you don't necessarily want to put sensitive information in those folders because they are world readable. However, for our cases, you can actually do a little bit more with them. So these come in the face of external files directory, which is very similar to our file directory for user data on this external partition. And in KitKat, we actually introduced the ability to have multiple external files directories. So in this case, you could have one external file on that internal/external storage and another on like your SD card. So this will be returned by the pluralized form of the method. Similarly for cache directories, same type of thing. And then also in Lollipop, we added external media directories. Now these are directories where you can write files to that are then read by the media scanner. So this is what allows other apps to get all of the images and videos and pictures that are in that folder and then make them available to other apps via the Media Store API. Now, the best part about all of these directories is that they don't actually require permissions on newer devices. So the other directory, which I really want to mention also for game developers especially, is the extension file directory, the OBB directory. This is where apps that are larger than the 50 or now 100 megabyte limit can store expansion files. These are actually shared across all users. So if you have a huge, large game on a tablet that's actually shared across all the storage, you're not penalized for having the same huge app installed multiple times. So the other part of this, right, those are app-specific directories. The next part is public storage. So these are the permanent files that survive your app being uninstalled. Now, for many users, this actually means that those files are never going to be touched, never going to be deleted, and may be orphaned forever, because the chances of many users actually using a file manager or going in or even plugging their Android phone into a computer are actually fairly rare. Many more users are just using the apps on their phone and don't actually realize that this public storage exists. Now, from that perspective, again, this is stored on kind of that external, but maybe not external space. It's called external. And the root of it can be get by get external storage directory. Right? But you probably shouldn't actually write files to that root directory, right? It's like writing to C:/ or the beginning of their directory. Like, maybe not the best idea. You can do it, but we'd much rather, if you were writing to this public external storage, use one of the directories that we've created. So there's one for pictures and notifications and ringtones and various other media types which auto-sort into these public directories. Now, an important part about this is if you have multiple users on the same phone, right, which is now possible, or on tablets, which has been possible back a number of versions, all of the external storage is actually sandboxed for each user. There's no way for your app running as one user to ever see data that's in another user's public directories. Even though it's called public, it's still sandboxed to that user. Right? That's more of a SE Linux thing than anything else, but is actually really important for things like Android for Work, where that separate user is, of course, totally self-contained and separate from your private data. So we talked about kind of what all these directories mean for the storage permission. So for those internal directories, the get filed or get cached, those can always be read with no permissions whatsoever. They're always going to be available to you. You can always write to them. They're great. And of course, they're auto-cleaned up when your app's installed. So it's really nice for users. Now, the external app-specific external storage has changed. In KitKat, we actually removed the need to use the storage permissions to read and write those directories. So if you were targeting pre-KitKat, you actually needed those permissions, even though they were app-specific directories. And we've lifted that restriction as of KitKat, so now you no longer need that. Awesome. Now, that external user storage, that public storage, that always requires the storage permission, right? We very much want users to be aware that apps are writing to this space that may potentially be taking up a very large percentage of their device's space, but are not actually attributed to that user, right? If a user goes in and says clear data or clear cache, those external files are not deleted. So unless the user is using a file manager, those files are not ever going to be cleaned up. And from a user's perspective, they might not know which files go to which app or which ones they can delete. Now, the storage permission is even more important in Marshmallow, because in Marshmallow with the runtime permissions model, the storage permission is considered a dangerous permission. That means if you're targeting Marshmallow and running on a 6.0 device, you'll actually need to request access to the storage permissions at runtime. You get this nice, mildly scary looking dialog that says, can they access all of your photos and videos? Right? Everything you've ever done in external storage, right? Which, yeah, that's true. That's part of the user's public external storage. But you have to think really long and hard of whether that's actually the right choice. Now, if you're saying, well, I only write to those app-specific directories, I'm good. There's actually a super easy way to remove storage permissions. You can use Max SDK version. Max SDK version just says, I want to use this permission, but as of KitKat, I don't need it anymore. I can safely remove it from my manifest. Users won't be bothered by it at install time. I don't need to worry about it for runtime permissions. You do this just by setting the Max SDK version in your user's permission in the manifest. And that's all you need to do to remove the storage permission, but still keep it around for those cases where you're running on an older device. But min SDK KitKat, that's not totally unreasonable, right? Maybe one day. Min SDK 21, that's even better. Now, this isn't to actually make your life more difficult, but really to just make it so that you can balance your needs as a developer to save files to the user's storage and their need for privacy and control when really giving your app the storage permission is asking for a lot of trust, right? Those are all of the pictures, all the videos that person has ever done on that device. And sometimes those are a little bit more sensitive. And part of that is that it's really all or nothing, right? There's not necessarily that requirement of saying, oh, well, I would really like access to this specific directory because of this all-encompassing nature of the storage permission. Now, part of this is just a complexity kind of reason. Users don't really understand what kinds of storage there are. Like, if you asked a typical user, all right, out of these 10 directories, which 4 of them would you like the app to be able to read to? That's a little bit harder than just a yes or no kind of an answer. Now, the one thing is that we want to avoid this, right? That's the whole reason we're here. So let's talk through some of the ways where we can really actually get a lot of this functionality, right? A lot of that communication between apps without actually needing these permissions. So what is this better way? Is there a different thing to do? And it turns out that we have a whole permissions model just for sharing individual files via URIs. Now, a URI, you might think of it as kind of like a file path, but it's actually a little bit different because you can apply URI-based permissions to it. Now, it really kind of started back in the beginning of Android with our intent system. That's the way of sending information or calls between different apps, right? You may say like a start activity and pass in an intent, and that's how you would then trigger another app to do things. These URI-based permissions are attached to that same infrastructure, allowing one app that does have the permission to access some file or resource, the ability to then kind of forward grant a permission to another app that doesn't have permission by itself. But via that intent system, they're able to then suddenly get permission to just that specific file. So this sounds like exactly what we need to do many of the operations between files, say sharing or something else, that we'd normally use files for. So there's actually 2 different ways of using URI-based permissions. One is just adding a simple flag to your start activity or start service intent. And these flags just say, yeah, any URI that's attached to this can actually be read by the receiving app or even written to by the receiving app. So this could be something, for example, like you include a image URI as well as the read permission. Now, all of a sudden, the other app can then read that image without actually requiring access to wherever that file is actually stored. In addition, you can actually programmatically grant and revoke these permissions. You can call grant URI permission with a specific package and say this package is always good to read any URI that's included. Similarly, you can actually revoke a URI permission. So this would be useful if like you're deleting an internal file and other apps have a URI to it. You may want to revoke all URI permissions to that file just so then it doesn't linger on. So let's look at kind of one of those common examples, right? The share button that you've seen hopefully in many apps, the actual share button, not some fake share button. And this is very common for using, say, sharing an image from your camera app to, say, a social media app. Now, if we were able to use external storage, right, the sending app might write it to some place in a public directory. And then the reading app would then need to have the read storage permission to then read the app. And of course, this will never work in Android for Work scenarios where the actual receiving app and the sending app are on two different users. So maybe we can use something else to actually get this across. And you'd think maybe, we just pass in our grant flag and we pass in our file URI and we're golden. There's one problem. File URIs don't work with URI-based permissions. File URIs are always protected by the underlying storage permissions. Right? You're directly accessing a file, and therefore you're going through that file system, which is the storage permission. So instead, we need to add just a little bit of indirection between our files and the other apps. And we can do that via a support v4 library class called file provider. Well, this is built on top of content provider, which you may have heard of and dislike or like in some cases. You don't actually need to write any content provider code, which is great. There's actually very little code to actually write in the file provider. What this allows you to do is actually give apps access to files in your get files directory, your get cache directory, or any of the get external directories. So these would be places where you can write without the storage permission, right? Especially on KitKat and above. But through file provider, now other apps can read those files. That breaks the need for any of the storage permission, because what we are sending is a URI and not a direct file path. And that allows us to use URI-based permissions. Now, there is some setup for a file provider. Specifically, every one of those file provider URIs has kind of a unique prefix, which we'll call the authority. Now, you can just define it as a static string somewhere, but I like to be a little bit more fancy. This is the limit of my Gradle knowledge. And actually define it in our Gradle file based on our application ID. So this would be kind of the package name in your app. And we can actually define it as a manifest placeholder. So now we can actually use it in our manifest file without having to reference the actual string. And we can reference it in our build config directories in any of our Java classes. And now it's always in sync. We only have one place to change it. And if we have multiple versions and build configs, it just works. So our manifest entry just defines our file provider. We're not writing any code so far. It's just a little bit of XML that you can paste right in, because all of the configuration is actually done by the file provider's path metadata. So this metadata is just a really simple XML file that you put in your res XML directory that just says what directories you're actually providing through file provider, right? What we don't want is we don't want every app to be able to read every file in get files directory and get cache directory. You may want to just have one directory that you make available, or in this case, 3 directories. You can have it read from the get file directory using the files path, get cache directory via cache path, and any of the get external directory via external path. Then the path is kind of that unique substring or subfolder within those directories. So that's all the one-time setup. You only need to do that once and then never touch it again, no matter how many share buttons you have throughout your app. Now we can actually share a file. So just like before, we'll have a file that we want to share. And then we can just use one method from file provider, our get URI for file method. And this takes in our build config and the file, and then spits out a special content URI. We construct our share intent, and then actually provide read access by calling set data with our content URI, and then adding the read flag. Now, the important thing to note here is that that add flag of grant read only applies, in this case, to URIs we've set in set data. So if we leave out that line, our grant flag won't actually apply to any URIs. So it's really important that those things kind of go together in almost all cases. On the receiving side, we can extract the URI, and then getting out the actual data out of that URI has a very simple method, get content resolver open input stream. Now the nice part about open input stream is it works for practically any URI you pass it, whether it's one of our file provider URIs, a file URI, or an Android resource URI. It's all the exact same code. From your receiver's perspective, it shouldn't matter how the sending app is sending that file across because you can parse it all in the same method. So right here, we just use Bitmap Factory to extract a bitmap from it. Now, the other thing that's nice about this is that you can actually daisy chain those permissions along. Say this is a receiving activity, but it's actually a service that needs to upload that file across. You can call the same set data and add the grant flag URI to your start service, and that permission will continue to daisy chain through different components, or if you want to send it to another app, you can continue to pass it along as long as you continue to use the grant flag URI. Now you may have noticed the file not found exception. So here's where things go horribly wrong. But it's also the most important part of sharing, and that's cooperation. It's a two-sided street. There's a sending app and there's a receiving app. Like I said, a lot of this relies on, in this case, the sending app to store it in the right place, to use file provider so that the receiving app doesn't need the storage permission. All right, if the sending app isn't doing a good job, is writing it out to a directory that assumes that everyone has read storage, there's not actually a whole lot you can do here except have read storage to read the file. Now, many Google apps employ a strategy where if it fails, then post a message saying, hey, I can't read that file. Like, the other app is trying to send me something that I can't read. Now, that definitely pushes the requirement back onto the sending app to do it correctly. So if you have a sending app that's doing it wrong, please fix it, because that's breaking everyone else, right? Now, hopefully, apps are testing with things like Gmail and other apps that are already installed on the system to make sure that it works. But same point, you can actually do that where we're setting the onus on the sending app. Now, you can take a different approach, right? Use that file not found exception as actually a requirement to say, oh, let me get the file permission, right? Say you're running on Marshmallow and using runtime permissions. Now that works. It would get the number of shares up to a higher percentage because you would be able to then say, oh, I don't have access to this. Let me see if adding storage permission helps me work around some of the bad apps that we're all fixing, like right now. Yeah. No? Okay. We'll give it a few more minutes. So that's one way to do it. But unfortunately, that means that your app then appears as using the storage permission. When you install the app, it says, hey, these guys are using the storage permission. Even in runtime model, you need to have a second dialog that pops up that users may not know, oh, well, I'm sharing a file over, right? And this works for other apps, but this app is saying now it wants to read all of my photos and videos. Like, I thought I was just giving it access to that one photo. Right? So you kind of have to deal with that different privacy model where maybe it makes more sense to say, I don't want the storage permission. I want to say, well, there's probably a different app on your phone that can give me that same information. Or maybe there's some cases where you can use a different technique which actually reverses the situation. And that's action get content. Now, get content's kind of the reverse, where we're asking for a file from a different app. And you do this simply by requesting it by a MIME type, say image/star to get any kind of image. I just want a picture, just give me anything you got. And then you want to immediately use that result in your app. Say, attach it to an email or send it to a friend via Messenger, what have you. Now, much of the logic here is actually exactly the same as action send, just in a reverse manner. He'll call action get content, passing in a request, and then the providing app, the one who the user has selected, will use file provider. Surprise, like who would have guessed? They'll use file provider, get URI for file, and then send that file back to the requesting app, and then open input stream to open the file, right? Very similar, but just in the kind of reverse model. Now, note, none of this code requires a storage permission, right? We're still asking from one file to the other, but it still works, right? We're using URI-based permissions, and because the user is actively included in the selection process, there doesn't have to be a blanket storage permission, right? Just by selecting, I only want to share these 2 pictures or something, then the user knows, oh, I'm giving this other app access to these 2 pictures. So we don't need a separate set of permissions on top of this. Now, the nice part about get content is you can actually do it with multiple files. So extra allow multiple true, and all of a sudden, assuming the providing app supports it, you can actually select multiple files. On the providing side, you'd actually add all of these URIs to what's called clip data. So this was introduced in API 16 that allows you to have multiple URIs covered by that same grant read permission. So before we had set data for a single URI, and now we have clip data for multiple URIs. Now you may be thinking, oh, API 16, I support gingerbread because I hate myself. Or I really love my users, right? There are lots of gingerbread users out there. We love them too. And it turns out that extra allow multiple was added in API 18, so not a problem for this case, right? In most cases for earlier APIs, they didn't have a concept of reading multiple URIs until after API 16. So in most cases, the set data is actually enough for the cases where you're not on API 16. So from our chart at the beginning, KitKat kind of changed a lot of things. It actually added a new action called action open document. So this is part of what we call the storage access framework, which is a really big, scary, easy to Google name if you need more information about it. But it works very similar to action get content via API. It's still an intent. It actually covers many of the allow multiple and category openable that we saw for get content. And of course, no storage permissions attached to any of the storage access framework. I wouldn't really be talking about it if it had storage permissions. That would defeat the whole purpose of my talk. But what it does allow you to get is actually additional APIs on top of that get content open input stream kind of API that we already have through document contract. So here we have different APIs of getting additional metadata about files, when it was last modified, lots of good information you'd expect from a file, but we're not providing file paths, we're providing access to documents. And better yet, all of these URIs actually have the ability to be persisted. So it's not just a one-time, oh, I want to read this one file, and then I have to create a copy of it, and then keep a separate copy for myself. You can actually say, I want to persist these URI permissions from anything included from the storage access framework. That allows you to actually have a list of things that go on forever, or track what things you've actually ever accessed. So are we supposed to just always switch to open document? Like, everyone's running KitKat, so we're fine. Now, pre-KitKat, you don't really have a choice. It is still get content. Open document won't work. You won't find any apps that do open document. It doesn't exist. But they really have slightly different purposes. So get content is that temporary access to a file, to our URI. So consider a case of like an image editing app. Get content could still be used for importing clip art or adding layers to an existing editing session, right? In that case, it doesn't really matter that you have direct access to the file forever. It's more that you want kind of that one time, oh, I'm going to paste this into the file, but I don't want the user to have to pick from a predefined list. I can use any file on their device. But for accessing the image, right, for our image mapping, we may want to use Open Document, right? Because then we would have persistent read and write access to that edited file. This allows us to actually save the edits directly to the file, overwriting it, right? Actually saving it where the user expects to find the file at a later point, which is great because if you've ever done an editing that has different copies, you'll somehow never find that edited photo ever again if you actually look for it. But if you have an open document, now you can actually save it directly over the file. You can also do really cool things, like say your editor wants a recently used list when you open it up. Like, let me shoot the last 5 images that you edited. Well, if you've persisted access to those URIs, now you can have a list of all of the images that you've had recently without having to figure out, okay, well, the user selected this file from somewhere and let me hope it's there. I can just use the URI that I already have. Now, one thing is that if that file that they selected something from was uninstalled, or say the image was removed from the source app, then when you call give me the URI again, it's not going to return anything. The file is gone, right? That's the whole reason behind the URI thing. But in many cases, that's exactly what you want, right? You don't necessarily want, from a user perspective, for them to say, oh, I've deleted this from my gallery, but there's still that app that has a copy of it, and that app has another copy of it, and then that second app doesn't even have a delete button or anything. So now I have this data that I don't really want on my device. But in fact, Open Document also allows document providers to provide delete access to other files. You may not even need to go back into the gallery and delete the app if you're using Open Document. You may actually be able to delete it directly from that app and say, oh, well, you know what? Like, I don't think we actually need this file. Now, you will probably want to check to make sure you actually have delete access before trying to just delete users' files. It may not always be the case. But there's one thing to be sure. Open Document is just better. So it provides all of the same functionality as get content in addition to this new functionality we've talked about, and frankly, a lot more functionality. So when you call Open Document, you're only going to get apps that support Action Open Document, right? That have a document provider, the class that they would need, on their side. Now, this means that you may get a more limited number of apps, but obviously, when you're using Open Document, maybe you're expecting that persistence or those new APIs. However, if you're on KitKat and above and you call get content, you'll actually get both. You get all the apps that support get content, as well as all the apps that support Open Document. Because anything you can do with get content can also be done on a document URI that you've retrieved via Open Document. The same opening, the same checking things on either one. Now, this does allow us to do some optionally cool things. There's actually a document contract is document URI. So you can check to see if your return result is actually a document URI, and then you can use those new APIs. And if they've selected something from a get content app, then you can just use just the default functionality. Now, the nice part is that even though you're getting these URIs, you can use a document file class, which is part of the Android support library v4, which kind of gives you a very similar API to a file for document URIs. So you can check, do I have read access? Do I have write access? Do I have delete access? All in a very simple API, and use it simultaneously for files and simultaneously for these document URIs, which is really nice. Very handy. Now, that does mean that if you're an app that supports get content and you support Open Document, you need to disable your get content on API 19 and above. Otherwise, users will see get content one in the list and your storage provider in the same list. So you disable one and say, well, Open Document can do everything that get content does, so I'll just have that appear in the list. You no longer need get content if you're using Open Document. So what does accessing the storage access framework look like from a user's perspective? So from their perspective, they're in an app, say our photo editor, and they hit the button saying, get me a file. Well, unlike get content, where they have to pick an app and then go into that app and have some custom UI where they select things, and then that app doesn't support multi-select, and then they're clicking on one and hitting load and clicking on a second one and hitting load. All of the UI for Storage Access Framework is done by the system. You don't need to write any UI to support the Storage Access Framework. You can just do just the data part of things. So this is really nice because then when a new version of Android comes out, you get even more functionality for free. You don't have to say, oh, I'm going to support this new stuff as much. Because what's happening is the system is the one who's reading from the document providers and giving new functionality. So, for example, in KitKat and above, coming with the system, you get internal storage, a document provider provided by the system, as well as if you plugged in a removable hard drive or something, you'd actually get a document provider for that removable hard drive automatically. As soon as you unplugged it, that document provider would disappear. That's great. Now people can select those files. In Marshmallow, we've extended that, so now when you have an SD card, you can do the same thing, and a storage provider will just instantly appear for the SD card. So now all of a sudden you can get write, read, and read directory access to the SD card for practically the first time ever. So we mentioned our action open document for accessing a document. Now, keep calling it a document. It's not necessarily a file on your local storage. It could be piped directly across from the internet. It could be in an encrypted blob on a specific hard drive. Doesn't particularly matter, because from the Readings app perspective, all you're getting is an input stream or a file descriptor that then you can stream the contents from, and all the metadata is handled separately. So you'll also get some other new ones. Action create document is kind of like the save button in an app, right? Where instead of you saying, oh, I'm just going to save it into this one directory that the user knows no idea of where that is, they can instead save it to Google Drive or save it to their removable storage. Doesn't actually matter where they save it because, again, you'll have access to that URI. You can get back to that file at any point. This is very different from the, I want to save it always in this one directory. Now, users can use different storage providers and switch between them. And then, if they want to select a file that maybe on a different device, they saved it to Google Drive, they go onto their other drive, now they can open document, select Google Drive, and suddenly get access to that file without you having to integrate with any SDKs or do any extra work, because Storage Access Framework kind of separates you from where the files are actually stored. Now, my personal favorite was added in Lollipop, and that's Open Document Tree. So this, instead of giving access to an individual file, now you get access to a whole document tree, or let's call it just a folder, because that's a nice name. You get access to the whole folder and all of its children, right? So in this case, you can actually say like, oh, well, where do you want me to save these backups of your app? And you can say, well, I want to store them on Google Drive and give them access to just one particular folder, not your entire Google Drive, because that's maybe a little scary and terabytes of data maybe, but just one directory. And then throughout the entire lifetime of your app, you can then read and write to that directory without additionally bothering the user of, oh, hey, where did you want me to put this file every time? You can have a default save location for new edits that could go into this file. Right? The choices are really very limitless when you're actually in that kind of setting. So implementing a document provider, kind of a few methods, not any content provider methods, even though it's actually a content provider underneath the covers. You'll notice we do that a lot. Because content providers are really great at providing URIs to other systems. That's how we do communication between devices, or between apps. Instead, you'll implement 4 methods: query routes, which is kind of the top level, like, I am an app that provides storage access framework controls, and this is my name, right? I want to be called Google Drive. That's a good name for the app Google Drive. Now, normally you just have one route, but you can actually return multiple routes. Say if you're logged into multiple users at the same time, you could have different accounts in here so that the user, without having to go into your app and select an account and then select which file, they would just appear as top-level directories in the Storage Access Framework UI. Now, query child documents and query documents are kind of what you expect. Information about all the things within a folder, and information about a particular document. And then open documents, really kind of the main key is the give me the bytes, give me the information about this file, right? And it may just be loading the file itself, or it may be doing something totally different, like streaming it across the internet and opening up a socket that persists forever. And that's the thing, from the app's perspective, it doesn't matter, right? From someone who's reading it in, again, doesn't particularly matter what the API is doing. It's just that open document exists, and suddenly it works. So there's actually quite a few resources about implementing it if you're one of those things who run Dropbox or Box or Google Drive or really anything you want. There's information on developer.android.com. I've built a sample app called Local Storage, which gives you kind of both a simple UI to test out all of these actions that we've talked about, as well as give you a sample storage provider which you can build upon. And then Jeff Sharkey, the storage framework engineer who's responsible for just about all of this stuff, wrote an example provider called Vault, which actually encrypts all of the files and then auto-decrypts it when you use them in storage provider. So very nice example of kind of going a little bit beyond just a simple open document opens the file underneath the covers. So to recap, what do we need the storage permission for? Accessing our internal apps specific directories? Nope, nothing there. External app specific directories, not above Lollipop. So we can use Max SDK 18. For sending files via action send, no, we got file provider, we're good. For receiving files or requesting files from other apps, no, not if everyone's doing their job right. But if you really do want to have that fallback of asking for the storage permission, really, really consider at most Max SDK 22. Don't specifically ask for storage permissions on runtime permissions model just because you want access to one file. In theory, hopefully Marshmallow will kind of push apps to be a little bit better in this range, because really we want everyone to be playing nicely. They don't need access to every one of the photos and videos that you guys have shot, especially if they're videos from Big Android BBQ. Don't share any of those ones. You know the ones I'm talking about. But really, we want to make the storage permission the exception, right? If you've booted up a Marshmallow phone and you look at the number of permissions, you'll note that storage permission is generally the highest one in count. And I would rather it be the lowest one in count, because really that means that those apps, unless you're a specific app like a file explorer or something like that, that needs access to all those files, you probably don't actually need access to all of them. So we've actually done a lot of work on that, even internally in Google now. Like runtime permissions are still a really big deal inside of Google as well. So for example, the next release of Google Maps, Android's SDK, is removing storage entirely. No longer need the storage permission to run any of the map stuff, which previously they were using. And even right now in 8.1, you don't need the storage permission on Marshmallow devices. So there's actually a lot of documentation on the Google Maps site that tells you exactly when those things are happening, and will surely be updated when the next version of Google Play services comes out. So thank you all for your time. My name's Ian Lake. You can catch me on Google+ or Twitter. I'm happy to help at all times. So I'll be down here for questions.